Okay, we are going to review for test 3. And for most of these, we'll use our time value many keys. So I will bring up the calculator when we get to that solving point. So we have Tom Blasting invested $1,000 in an investment that he expects to pay 12% compounded quarterly for 3 years. Find the compound amount and the interest. So our N, it is 3 years and it compounds quarterly. So that's 4 times a year. So 12 is going to be our N. The IY is 12% compounded quarterly. So we're going to divide that. 3 is going to be our IY. The $1,000, we will make it negative. That is our PV. No payments yet. And then we will compute the FV. So now if I bring up my calculator, see if I can scoochie it a little bit. Okay. So we've got, let me make sure I'm going out all decimals. So second in my decimal, I want that to be 9 and then push enter. So 12 is my N, 3 is the IY, 1,000, 1,000, make that negative by hitting the plus or minus button, is our PV. No payment, so we'll zero that out and then compute the future value. So 1,425.76. And then if it wants to know what is your interest, the 1,425.76 minus the $1,000 you started with is 425.76 in interest. So we'll come back, over there. So our compound amount was the 1,425. Let's see, can I put that back there? Okay, 1,425.76. And then the interest is 425.76. Okay, then question 2. Let me see if I can erase those. Okay. Sharon has $20,000 to invest, and she believes that they will earn 4% semi-annually. Find the compound amount if they invest for 2 years or 13 years, and then find the additional amount earned. So 2 times 2, semi-annually is twice a year. 4 is going to be our N. 4 divided by 2, 2 is going to be our IY. 20,000 plus or minus is our present value. No payment at this point. And then we're going to compute the future value. Okay, so we'll come back here, bring that calculator back up. So 4 is our N, 2 is the IY, 20,000, make that negative, is our PV, zero out the payment, and then compute the future value. So 21,648.64 is our future value. Now then, all we have to do is go back into our calculators. Again, because the IY doesn't change, the present value doesn't change, the payment doesn't change. All that changes is our N. So if we go 13 times 2, our N becomes 26. And then if we just recompute that future value. So coming back to our calculator, again, all we got to do is push 26, push the N, and then compute the future value. So 3346836. So that would be our difference. And then we will subtract those, I guess, to get to the difference. Okay, so 33,468.36 minus 21,648.64 gives us 11,819.72. So then we'll come back over here. See if it shows it. You gotta put it in here. All right, so 21,648.64. 33,468.36. And then the difference is 11,819.72. So it's always nice, though, when it is all the information stays the same and you don't clear your tables. All you have to do is change the n to determine what those changes will be, and then you compute the future value. Oh, just clear. Okay. All right, then we'll circle back here, say next. A tire company has $190,000 to invest for 1 year. Find the future value if it earns 2% compounded daily or 4% compounded daily, and then find the interest between them. So again, similar deal. So 365 days is what's in a year. So that's our N. For these ones, I always just put it into the calculator. So 2 divided by 365, push equals, and then push the IY button. 190,000, hit the plus or minus button, and then push the PV button. No payments yet, and then we'll compute that future value. So again, coming back to our calculator, 365 is our N. Then take 2 divided by 365, push equals, and then push the IY button. 190,000, push the plus or minus button, and then the PV button, zero out that payment, and then compute the future value. So 193,838.15. And then, like I said, if all we've got to do is change the IY, it's the only thing that changes. So then we go down and take 4 divided by 365, push equals, and then push the IY button, and then we'll recompute that future value. So again, all you got to do, 4 divided by 365, push equals, push IY, and then now compute the future value. So 197,753.61. Did I say that one right? Let's double check. 197,753.61. Yep. Okay, then we want the difference between those. So 197,753.61 minus 193,838.15. And that gives us, I must have keyed it in wrong. Sorry, let me do it again. 197,753.61 minus 193,838.15. And that gives me 3,915.46. All right, so come back over here. 193,838.15. Okay, then 197,753.61. And then the difference, 3,915.46. Okay, Southwest Dry Cleaners believes that it will need new equipment in 10 years. The equipment will cost $26,000. What lump sum should be invested today at 5% compounded semi-annually? So let me go back here. How did I do that last time? Clear Canvas. Okay, so go back here. And we've got 10 years, and it is compounding semi-annually. So 10 times 2 gives us 20 as our N. 5 divided by 2, again, 5% compounding semi-annually. 2.5 is our IY. What lump sum should be invested today tells us we're computing for the present value, so we'll skip over that. There's no payment yet, and that $26,000 is a future value. And then we will compute the present value. So again, always look for your keywords to know what you're looking for. So 20 is the N, 2.5 is the IY, no payment, so zero that out. $26,000 is our future value, and then compute the present value. So 15,867.04. So that would be B. It's again, couple cents off. Remember that when we use the calculator, we're going to be a little bit more accurate than the tables. So don't worry about those couple cents. Find the amount of the ordinary annuity rounded to the nearest cent, and then find the interest earned. So the annuity clues us in that now we are having the payments. So we've got 20 years as our N, 8 as our IY, again, because it compounds annually, so we don't have to do anything. There's no present value, but there is a payment. So $1,000 is being deposited every year. And I'm going to make it negative because I don't have a present value. And then we're going to compute the future value. So coming back here, 20 is our N, 8 is the IY, zero out the present value, 1,000, hit the plus or minus button to make it negative is our PMT or our payment, and then compute the future value. So 45,761.96. That would be our future value. And then the interest, we're going to take the N times the payment, because that's how much money they put in. So that would be 20,000, and then take the difference between those. So that would be 25,761.96. All right, so the first one is 45,761.96, and then the interest earned is the 25,761.96. Okay, then the person deposits $1,400 into a mutual fund containing stocks at the end of each semi-annual period for 17 years. Assume the fund earns 10% compounded semi-annually. Find the future value. So again, they're depositing that at the end of each semi-annual period, so that tells us that that is their payment. So 17 years times 2 for semi-annual gives us 34 as our N. 10 divided by 2, since it's semi-annual, gives us 5 as the IY. No present value, so we'll go ahead and zero that out. 1,400, and I'll make it negative by hitting the plus or minus button since I don't have a PV, is my payment, and then I'll compute the future value. So 34 is the N, 5 is the IY, zero out the PV, 1,400, hit the plus or minus button, make it negative, push the PMT button, and then compute the future value. So 119,093.74. Make sure I got that in there right. 119,093.74. Okay, then now find the present value of the annuity. So sometimes, especially if we're making withdrawals for like college or for retirement, we come back and we want to compute the present value of these future withdrawals. So for this one, we have quarterly payments and for 12 years. So 12 times 4 gives us 48 as our N. 8% divided by 4 gives us 2% for the IY. Again, we're computing the present value, find the present value, so we'll skip over that. 2,600 is the payment, and because I'm computing the present value, I'll let the payment be negative or be positive. There's no future value, and then we'll compute the present value. So come into the calculator, 48 is our N, 2 is the IY, 2,600 is the payment, no future value, and then now come back and compute the present value. So $79,750.11. So that is our present value of that future annuity. Two employees of a real estate company prepare bids for the purchase of land. Offer A is an immediate cash purchase of $280,000. So offer A is what it is. We don't have to do anything. So then we got to compare that to offer B. So offer B, we have $89,600 cash. So we don't have to do anything to that either until we get to the end, then we just got to add it. But then we're going to have an annuity at 8% compounded quarterly, yielding payments of $11,424 to be paid quarterly for 5 years. So 5 times 4 gives us 20 as our N. 8 divided by 4 gives us 2 as our IY. We are bringing this back to a present value, so that's what we're computing for because we want to make everything in today's terms. So the $11,424 is the payment. There's no future value at the end, and then we will compute that present value. So come into our calculators. 20 is our N, 2 is the IY, 11,424 is the payment, no future value, so zero that out, and then compute the present value. So 186,798.77, and then we have to take that, take that number and then add the cash price to it, and then we'll compare. So then 186,798.77 plus 89,600, and that should be a comma. That gives us 276,398.77. So offer A is better by a little bit, so it's not a lot. So then if we compare them, subtract that from 280,000, it is better by $3,601.23. So don't get confused with the cash down. Those you don't have to do anything in your time value money keys. You just have to remember to add them back to the present value. Okay, a medical center needs $818,000 in 2 years for a new lab and equipment. Find the amount of each payment if the payments are made into sinking funds at the end of the semi-annual period with interest at 12% per year compounded semi-annually. So we got 2 years compounded semi-annually. Let me go back there. So 4 is our N. 12% per year compounded semi-annually, so divide that by 2. 6 is our IY. We're not starting with anything today in these sinking funds, so our present value is always 0. We're computing for the payment The 818,000 is a future value. So we'll put that into our calculator. 4 is our N, 6 is the IY, 818,000 is our future value, no present value, I think I skipped over that, and then compute the payment. So 186, 987, 84. And then we're going to compare that to the payment, or so we're going to take the payment, we're going to multiply that by the N. So the 186, 987, 84 times 4. That gives us 747,948.16. And then we'll compare that to 818,000. And then the difference is $70,051.84 that they will have made in interest. So the periodic payment is 186,987.84. 186,987.84. And then the difference is 70,051.84. And then another sinking fund, the dealership wants to build a new showroom for $2,500,000. It set up a sinking fund with end of the month payments in an account earning 12% monthly. Find the amount that should be deposited in this fund each month if the dealer wishes to build the showroom in 3 years or 5 years. So we've got 3 years, 3 times end of the month, whoops, so 3 times 12, 36 is our N, 12 divided by 12, 1 is our IY, no present value. We're computing for the payments if we want to have $2,500,000 as our future value. Oops. So again, coming back to our calculator, I can scooch that over a little bit. Okay. 36 is our N, 1 is the IY, 2,500,000 is the future value, no present value, and then compute the payment. So 5835.77. And then what if we go 4 years? So again, when we have those ones and we're making a comparison, the nice thing is all we have to do is change our N. I feel like that's in my way. I wish I could. Okay. Well, I'll just come down below it. All right, so then 4 years, 4 times 12 gives us 48 as our N, and then we're going to recompute that payment. So 48 is our N, and then compute the PMT. So 40,834.59. Okay. Okay, then here we'll come back here, clear that canvas. Okay. Ignore commissions, find the cost of the following stock purchase at the opening price for the week, and then find the annual dividend paid on those shares. So it's Alphabet GOOG. So if we look in here, Alphabet GOOG, we have 107.69 as our open. We have what else is it asking for? I guess let's here the dividend. The dividend per share is 0. So as we come back here, let's go back. Let's close that. So we're buying 520 shares times the 107.69, which was the open. So that gives us 55,998.80. And then there was $0 for the dividend. So we don't have to do anything to compute that. So 55,998.80 and then 0. The stock of a company has a current price of $67.56 and an annual dividend of $3.89. So again, we'll clear this out and we'll calculate that. So that you take the dividend, the yield of the stock is going to be the dividend of $3.89, and we're going to divide that by the $67.56 that we paid. Whoops, so that's $3.89. Okay, so 3.89 divided by 76.56 gives us 0.05757, or 5.8% if they're having me round to the nearest 10. Okay, then we have bonds. Now, what you want to remember with bonds is that the bonds are sold in $1,000 increments, and what we see here is not in dollars and cents, it's percentages. So if we are buying 15 bonds times $1,000 a bond times the last price. So that's 100.422%. So if we put that, and then we'll have to plus $1 too though. So 15 times 1,000 times 1.00422, putting that in a decimal. So that's 15,063.30, and then 15 times $1, we have another $15 that we need to add to that. So that's 15,078.30. So just remember, $1,000 is how each bond is sold, and these are all percentages. All right, Kyle places $30,000 in a bond fund that is currently yielding 8% annually. Find the interest for the first year. If Kyle decides to let all interest payments remain in the account and the fund earns 8% compounded annually, find the amount after 15 years. So the first one is just our basic interest equals principal times rate times time. We're not doing anything with the time value of money at that point. So the principal is 30,000, the rate is 8%, and then our time is 1 year. So 30,000 times 8% gives us 2,400. So that's our interest for the first year. Now then, sometimes students struggle with this second one. We're going to go back to our time value of money keys, because that's if the interest is staying in there, that's exactly what the time value money keys factor. So 15 is going to be our N, 8 is going to be the IY, the 30,000 is going to be the present value. There's going to be 0 payments because again, there's nothing separate coming in. We're just letting the interest ride, and then we compute the future value. So coming back to our calculator, 15 is our N, 8 is the IY, 30,000, whoops, I'll make it negative by hitting that plus or minus button, is PV, no payment, so 0 that out, and then compute the future value. So 95,165.07. Okay, Then this one, we will not use our time value of money keys. This is our why am I struggling to get this to go away? This wasn't far enough. There it is. Okay. So this is the one where we set up the kind of like the table. So we'll have our date, then we'll have a transaction, and then we'll have a balance. I want it to go longer than we'll let me go all the way out. Okay. And then we'll have our days outstanding. I'm going to abbreviate that as days OS. And then that's going to equal a total. I mean, once we get through the math. So our first date is on May 17th, and we don't have a transaction, but we do have a balance. So our balance is $459.21. And then we want to know, well, how many days was that outstanding? Our next transaction is on the 19th, so that's 2 days. And then on the 19th, we have a return. So we're going to reduce our balance by $62.45. So then the $459.21 is reduced by $62.45. So that takes it down to $396.76. And then we say how many days did we have that outstanding? Our next transaction is on the 25th. So that is 6 days later. I don't understand why I can't move that little box. It's right in our way. It doesn't let me move. Oh, that's going to block that. Can I delete it? Nope, deleted the whole darn thing. All right, undo. Oh, guess it doesn't work like that. Okay, that's kind of a pain. All right, so start back over. I just didn't like it that it was over the, okay, so date, transaction, balance, times days outstanding, and that's going to give us our total. Okay. So our date again is May 17th. No transaction, but we do have the balance of the $459.21, and we determined that it was 2 days outstanding. And I might just go ahead and add these up here, or just go ahead and do them as I go. So that is a total of $918.42. Then on the 19th, we have a return of a negative $62.45. So then our balance goes down from $459.21 minus $62.45. So the balance goes down to $396.76, and that is for 6 days. So that's $2,380.56. And then on the 25th, we make a purchase. So if we make a purchase, our balance goes up $134.76. So again, it's under the little icon there, but it was $396.76, and we increased it $134.76. So that's $531.52. And we had that for 3 days. So 1594.56 is our total. Then on the 28th, again, the balance is going to go up because we're making a purchase, $45.65. So we add $45.65, then the balance goes up to $577.17. And then we say how many days did we have that outstanding? Well, there would be 3 days to get to the end of May and then 3 days into June. So that's going to be 6. So 346, 3.02. And then on June 3rd, we have a payment of 175. So we're going to reduce it. And that goes down, the balance then goes to, 577.17 minus 175. So 402.17. And then you look to say, well, how many days was that outstanding? So you have to remember there's 1 month between the billing dates. So the next billing date is going to be June 17th. So that would be 14 days later. And that gives us 5630.38. Okay, so then we come down and we add up our totals. And again, I'm just a little annoyed I can't get this to move because now I don't know what my total was underneath of there. All right, here went away for a second. Darn it. I wanted to go away more than that so I can see it. I should have jotted that number down. 2380. Okay, there it is. Okay, so add these up. So 918.42 plus 2,380.56 plus $1,594.56 plus $3,463.02 plus 5630.38. So that gives me a total of 13,986.94, and then I'm going to divide that by my number of days. And then it's May, and there should be 31 days that we accounted for. So we're going to divide that by 31, and that gives us 451.19. And again, always double check that that seems like a reasonable amount, but it does. So that's our average daily balance, 451.19. And then that's what they're allowed to charge us finance charges on. So we'll multiply that by 1.5%. And that gives us $6.77 as our finance charge. And then finally, the last thing it asks for is what is your balance? So the $402.17 is where it ended. And then we got to add the $6.77 finance charge to that. So that gives us $408.94. Okay, come back over here, clear that. Then we have getting into our loans. So Pat bought a new car for $19,700. She made a down payment of $1,500 and agreed to pay 60 payments of $391 each. Find the amount financed, the installment cost, the interest paid, and the annual percentage rate. So the amount that she bought the car for, or agreed to buy the car for, $19,700 minus $1,500 that she put down is going to be the amount financed. So that is $18,200 is that first answer. Then the total installment cost is how much they pay out of pocket. So they're paying 60 payments times $391. So 60 times 391 gives us $23,460 plus the $1,500 that they paid down. So $24,960 is our total installment cost. Then the interest paid, so you could do this two different ways. So if you take the total installment cost, $24,960, and then you subtract the $19,700 that you agreed to buy the car for, the difference in that is the finance charge, so $5,260. And then finally, the annual percentage rate, I put that into the calculator. So we've got 60 payments, 60 is our N. We're trying to figure out the IY, that's what we're looking for. The amount that they financed, 18,200 plus or minus, make it negative, is the present value. $391 is the payment. Now that's positive. No future value ever on a loan. And then we'll compute the IY. So let me go push this back up, get to the calculator. All right, so come into the calculator. Again, 60 is our N, 18,200, hit the plus or minus button to make it negative is the PV. $391 positive is our payment. Never a future value on a loan, so zero that out. And then compute the IY. So remember, it's a big, long, weird number. So 0.87325. And additional. And then we're going to take that and multiply it by 12 because they want to know the annual percentage rate. This is the monthly. So while I have that all in there, I'll just multiply by 12 and then push equals. So basically 10.48 or 10.5 if we round it. Okay, then we want to calculate the payment. Again, we don't look at that table. Don't look at the table. Find the payment required to amortize a loan of $5,400 with annual interest rate of 17% and a term of 42 monthly payments. So come back here, clear that canvas. And then our 42 is our N. 17 divided by 12. Let's see if that's a big number or not. Yeah, so we'll go ahead and just put that into the calculator. That's our IY. 5,400, make it negative, is the PV. We're no future value on a loan, and then we're computing for that payment. So 42 is our N. 17 divided by 12, push equals, and IY. 5,400, hit the plus or minus button to make it negative, is the PV. No future value, and then we'll compute the payment. So $171.47. So that's the amount of the payment. Then the finance charge is going to be your number of payments times your, so 171.47 times 42, so your N times your payment. And that gives us $7,201.74. And then we'll subtract the $5,400 from that. 1801.74. Okay, then we're going to amortize. So the first thing we have to do when we amortize is to put them into our time value money keys, and then we can get into that amortization function. So we have Murray Countertops borrowed $6,000 at an annual rate of 3% to buy a used forklift. Murray amortized the loan in 4 annual payments, and then we will prepare that table. We'll just answer the question. So we've got 4 as our N, 3 as the IY, 6,000 as our PV, no future value on the loan, and then we'll compute the payment. So coming back to our calculator, 4 is our N, 3 is the IY, 6,000, again, I'll hit the plus or minus button to make it negative, is the PV, no future value on a loan, and then compute the payment. So 161416. Okay, then we'll go into our second menu button and the PV, which takes us into the amortization function. And then we'll make our P1 equal to 1. Oops, and our P2 equal to 1. And then we will look for the interest. So if we come back to our calculator, again, the second menu button and the PV button, P1 is equal to 1, P2 is equal to 1, arrow down until you get to the interest. So 180. And that will go here. Okay, then it says, what about the principal of the second payment? So now we're going to make P1 equal to 2, and then we're going to make P2 equal to 2, and then we're going to go down and look for the PRN. So if I just arrow down, I go back to the top. So P1 is equal to 2, push enter, arrow down. P2 is equal to 2, push enter, arrow down. And then our principal is 147719. And that goes here. Then we'll come down and we'll do it again. So our P1 is going to be equal to 3. Our P2 is going to be equal to 3. And then now we want to go look for the balance. So again, arrow down, P1, 3, push enter, arrow down, P2, 3, push enter, arrow down, and the balance is 156715. Okay, then we have a mortgage, and you'll have one very similar to this on your test. And what you want to remember is this is monthly. Notice it says it right there, monthly payment. Probably a third of the students will just do it like it's annual. If our mortgages were annual, we all would be homeless. Okay, so 10 times 12 gives us 120 as our N. 6 divided by 12 gives us 0.5 as our IY. The loan amount is $99,000. Hit the plus or minus button to make it negative. That's your PV. No future value on a loan. And then we will compute the payment. So we'll come over to our calculator. 120 is our N. 0.5 is the IY. 99,000, hit the plus or minus button to make it negative, is the PV. No future value on a loan, and then compute the payment. So $1,099.10. Now that's not our total monthly payment though. That is just for the loan. We got to factor in escrow. So our annual taxes are $1,150. Our annual insurance is $540. So add those together. So that's 1,690. And then we're going to take the 1,690 and divide it by 12. We want a monthly average of that. So 140.83. And that will go into escrow. So $1,099.10 plus $140.83. That's going to give us our whole monthly payment. So $1,239.93. And then our last question is the bond. And we're going to use our time value money keys for that. So assume you're trying to estimate the price you'll pay for the bond. The face value is $1,000. The coupon rate of interest is 8%. The bonds mature in 20 years and are currently priced to yield 7.25%. Compute the present value of the bonds. So hint, you must compute the annual interest payment using the coupon rate, and the yield rate will be your IY. So our N is going to be how many years it is. So 20 is our N. The yield rate, the 7.25, is our IY. The present value is what we're solving for, so we'll skip over that for now. The payment is at the 8%. So $1,000 times 8% gives us $80. Whoops. And then the future value is always the par value. That's how much the company pays you back. Now notice both the payment and the future value are positive. Do not make one of those negative. When we compute the present value, it will be negative. Okay, so putting that into our calculator, 20 is our N, 7.25 is the IY, $80 is the PMT, $1,000 is the future value, and then compute the present value. So $1,077.93. So that is D. And then we say, yes, we are good to, we missed half of this one. I wonder which one it is. It might be that APR one. Let's see. Oh, did I just click the wrong box? I must have just clicked the wrong box on that one. Sorry about that. Because then our second answer was correct. All right. So that again will help you prepare for your test. Now this test, you will have the box to show your work within the test. If that is time consuming and you don't like to do that, you can write it on paper and then send me a picture of your work via email. All right, good luck.